everyone, welcome back. Last time we talked about some applications of machine learning, and now we're going to be getting into a little bit more of the mathy and the algorithm side of um, machine learning. And a subset of machine learning is deep learning. So we're going to talk about this today. So, what is deep learning? So, a type of machine learning that deals with the use of artificial neural networks, which with many layers to extract features and learn from data. So, I think we talked a little bit about neural networks, scratched the surface, but essentially they are a type of algorithm that is applied through um, complex mathematical equations, and they we'll see how they work, but they're used in what's called deep learning. So it's this whole subset of machine learning that you can use to extract features and learn from the data. And how are these used? Neural networks are constructed from code to complete tasks like recognition, classification, detection, and natural language processing. Okay. Neural networks. So, what are they? Neural networks are the architecture of deep learning that models the human brain and is built off several layers to process data and make calculations. So, in our brains, we have neurons, and essentially, they're like connected through this like string of a bunch of, if we could call it like wires, or like through signals they transmit signals through these complex pathways, and that's kind of what a neural network is doing. You're putting this information into this pathway and it hits different neurons, and that has some signification to what comes out of the model, what comes out of the signal. And then how do they work? So data flows through the hidden layers. So there's many hidden layers within a neural network. Well, there can be just not a lot, but there can be many. It just makes determines if the model is more complex or not. Um, so it flows through the hidden layers within a neural network with weights to sway the model to have a higher accuracy. The process of weight adjustment and hyperparameter tuning plays a big part in training and testing neural networks. So this is like a closer look on how it actually works mathematically. So we have this x1 value and this x2 value. So the data is going into the model through these ports, and then through W11. Um, W11 is being multiplied uh, here by x1. So there's like that is kind of like the weight that's happening. You're multiplying W11 by x1, and it's taking this feature or this subset of the data or whatever, and is putting some assigned value to it that gives it its importance, and that ends up turning into y. And that weight helps us with determining what's most important to the model, and it helps us get better feedback, better accuracy. Forward propagation. So this is the kind of process of putting the data into the neural network, going through the neurons, going through the hidden layers. So at the input layer, you just feed your model the raw data. So whether this be pixel value or numerical data, whatever you're doing, you're putting the raw data into your model. And then it goes through all these hidden layers. So in each hidden layer, neurons are assigned a weight which signifies its importance in the model. And then it calculates a weighted sum of its inputs before passing through an activation function, which assigns the sum a value that represents its final output or accuracy. Through each layer, the model becomes able to pick up on more intricate features of the data set, making a neural network with more hidden layers more intricate. So essentially, the data is flowing through these neurons, and based on which neuron it's flowing through, it's being assigned a certain value that's giving it either multiplying it by a higher value or a lower value. So it's all based on these mathematical equations, and then from that value, the model tells you yes or no. It gives you some sort of this activation function that turns that value into something that's more binary. So instead of a range, it's like 0 or 1, yes or no, and that makes it easy for us to see its accuracy. And once we look at an actual code for this model, we can see more what the activation function is. And then if we have more of these hidden layers, it kind of is like learning in a way. So if you have more tests, more studying, it's kind of like thinking about it like that. If you have more different places where you can learn this information, you're going to get better at understanding the data as a whole, and it's going to make your neural network more complex. And then repeat. So the output can then be passed through several layers of neurons depending on the model to further transform and process the data. So you can have more hidden layers, and just repeat the process. And this goes into back propagations and adjustments. So first of all, you're going to want to compare. So the original prediction of the model is then compared to the final output, and an error is calculated. Then machine learning engineers decide if tuning is needed. So essentially, before you even run through the model, you have a kind of prediction to see what the accuracy is going to be. And then once you actually have everything run through your model, you get your accuracy. You can use different scores to represent this. And there's actually some more complex scores. You can use like an F1 score. This will calculate more of like the precision and can give you some more feedback on more than just your accuracy, because sometimes you can see you have a high accuracy but you have a really low precision. So there's a lot more complexities to how well your model works than just the accuracy. But using the accuracy in the output, you can calculate this error, and then we can look and see, is there a really big imbalance? Do we need to fix something within the model to make this better? And that's where it comes into adjusting everything, adjusting the features, adjusting certain parts within the neural network to get a higher accuracy. And it's really just a repetitive process that you have to go back and fix things, adjust things, see how things work with this certain number of neurons, and just it's really an iterative process. And in most cases, it is needed. So if you are ever working with a neural network and your accuracy is not close to your precision or your prediction, don't worry, it's pretty normal. It's just part of the process to have to adjust it, and that is how machine learning exists now. But maybe in the future there'll be some way to make it easier. Back propagation. So the model uses this error value to adjust the weights and the biases within each layer to receive a higher output. So once this error is calculated, the model kind of goes in and says, in this neuron, this weight needs to change to get a higher accuracy. So it's kind of self-adjusting, but there is also a lot of engineering that goes into it besides the actual model adjusting itself. And then iterative training. The network continues on this cycle to learn the data well, gradually progress in its ability to analyze patterns and produce a higher accuracy. So it just keeps going on and on. It's definitely a process. It's definitely something that's going to take time, and but that is okay, because making your model better is all you want. And it's also important to maybe sometimes not get a good accuracy. It all just depends on what your project is and what your data you're using. But we never want to kind of sway the data. Well, obviously there's going to be sways in the data with the biases, but these are what the model is picking up on to make it a fair accuracy. But we don't want to change anything about the features to make unwanted bias within the model besides the ones that are already there to help our accuracy. We don't want to make more biases that are going to actually give inaccurate, well, actually it could be high accuracy, but they would not be authentic or truthful results. So we want to keep that in mind as well. Okay, next time we're going to get into a little bit more about how these neural networks are coded and some more algorithms. Thank you so much.